So we're going to look at a method of solving linear systems, meaning finding the point of intersection of two lines, called elimination. A system of linear equations is best solved using elimination when you don't have a coefficient of 1 in front of any variable in either equation. So for instance, in this question, 9y plus 6x equals 18 and 10y minus 4x equals 20, it's not that easy to isolate one of the variables by themselves. So meaning solving for x in one of the two equations or solving for y in one of the two equations, as we would in substitution. So we like to use the method of elimination. Now the first step in this method is to multiply each equation by some different number, some different constant, so that the coefficients of one of the two variables lines up. Meaning we have the same number in front of the x in each equation, or we have the same number in front of the y in each equation. It's totally up to you whether you want to match the x coefficients or the y coefficients. 6 and 4 looks a little bit more manageable than 9 and 10, so I'm going to choose to line up the x coefficients, but that's totally your choice. So really I need to think about the least common multiple of 6 and 4 in order to line up the x coefficients. Now I note that if I multiply equation 1 by 2, that's a times symbol, not a x, so maybe I'll write a dot, and I multiply equation 2 by 3, my linear system becomes 18y plus 12x equals 36, and 30y minus 12x equals 60. Now, this is really good. I have a 12 in front of both x's. One's a positive 12 and one's a negative 12. So, as I know, 12 plus negative 12 gives me 0. So if I add these two equations together, I get 48y plus 0x. You don't have to write this 0x. I'm just doing it to kind of show a point, equals 96. Okay, great. So really, I should write that as 48y equals 96. So now I have one variable. It's a linear equation, one variable. I know how to solve that. I just divide both sides by 48, and I get y equals 2. So I've eliminated the x. Note that if I had the same sign in front of the x in each equation, meaning both positive or both negative, right? You see here I have opposite signs. I have 1 plus and 1 minus. Rather than adding the two equations, I could have subtracted the two equations. So positive 12x minus 12x would have been 0, or minus 12x minus negative 12x would have been 0. So in this step, it's crucial to decide whether or not you want to add the two equations together or subtract the two equations. Okay, so now that I have y equals 2, I know the y coordinate, the point of intersection of my two original lines is 2. I can find the x coordinate by plugging y equals 2 into either of the two original equations. Whichever one looks more manageable, I will do. I'm going to choose to plug it into the second. So 10y minus 4x equals 20. And I know that y is 2, so 10 times 2 minus 4x equals 20, meaning 20 minus 4x equals 20, and I solve for x, and so x equals 0. Now therefore, the point of intersection occurs when x and y equals 0, 2. Remember to write your x and y in the correct order. And that is the method of elimination.